Welcome to Lakshmi Chemistry channel. Mesomeric effect or resonance effect. If a single structure fails to explain the observed properties of the compound, then two or more structures are proposed to explain its properties. The actual or true structures of the molecules will be a resonance hybrids of all the structures, and these structures are called resonance structures or canonical structures. Resonance structures are also called as canonical structures. Canonical form should have the same position of atoms. The number of lone pairs and unpaired electrons must be same. The stability of the compounds is depending on the number of canonical forms. If, for example, more the number of canonical forms, greater will be the stability of the compound. And here the mesomeric effect. Mesomeric effect means if in case of any compounds are having conjugated pi system, any compounds are having uh, conjugated pi system. Conjugated pi systems, electrons can flow from one part of the system to other part due to resonance. The flow of electrons from one part of conjugated pi system to other caused by the phenomena of resonance is called resonance effect or mesomeric effect. This resonance effect this effect is two types. One is plus M effect, and second one is minus M effect. Plus M effect means if electron donating groups conjugated electron donate groups directly attached to the conjugated pi system. That means if a group donates electrons to the conjugated pi system through resonance, then it is said to have Placium effect. For example, in this example, chlorine donates electrons to the pi system. Chlorine donates electrons to the pi system. For example, in phenol, you can observe this phenol. Phenol in phenol, oxygen is having two lone pair of electrons. One of the lone pair of electron donates to the aromatic ring system. Here, these are the resonance structures of phenol. Resonance structures of phenol. For example, plus M groups. For example, fluorine, bromine, iodine, NH2 groups, NH2 or OR groups or ESH group. SH group, those are all are plus M affecting groups. Means electron donates to the conjugated pi system. Next, minus M effect. Minus M effect means groups which electrons towards themselves through the resonance are said to have minus M effect. These are the compounds, for example, COOH, CN, CHO, and CO or NO2. Those are all are minus M affecting groups. In this example, for example, you can observe this nitrobenzene. In this nitrobenzene, the pi electrons of benzene ring shifted towards NO2 group. Here, benzene is having positive charge, and these are the resonance structures of nitrobenzene. Here this carbon is having positive charge. That means these pi electrons are shifted to in between these two carbons. Then this carbon is having positive charge, then these pi electrons are shifted to these two carbons, then by positive charge on this carbon. These are the resonance structures. That means the shifting of positive charge on all the carbons of benzene ring. This is minus M effect. What is plus M effect means electron donating effect. Minus M effect means electron withdrawing effect. Then next applications. Applications of uh, applications. First one acidity. Acidity. Acidity of phenol. Acidity of phenols. Phenol means what is this? This is the phenol. Hydroxybenzene is called phenol. Phenols are weak acids. The acidity of phenols is due to their donating proton, their proton donation. For example, phenol on hydrolysis it will give phenoxide ion C6H5O minus plus H3O plus. That means this is the donation of proton. That's why phenols are weak acids. The equilibrium position of this equation is depending on the relative stabilities of phenol and phenoxide. Relative stabilities of phenol and phenoxide. This one is the phenoxide ion. Phenoxide ion. This phenoxide ion is more stable when comparing with phenols. Phenoxide ion is a more stable than phenols based on resonance. That means hence the equilibrium lies towards the towards right side of the equation. So phenols acts as proton donors. You can observe uh, these two. You can observe these two resonance structures, phenol and phenoxide ions. Also, you can get the phenoxide ions are more stable than phenols. If phenol resonance structures in resonance structure negative charge on benzene ring, this negative charge is delocalization, and you can observe here in phenol resonance structures, oxygen is having positive charge. Oxygen is having positive charge. Oxygen is a high electronegative atom. High electronegative atom. It donates electrons to the benzene ring and it cannot be bearing positive charge on it. It is less stability. When comparing with phenoxide ion, in phenoxide ion there is no charge on oxygen atom. There is no charge on oxygen atom. Same negative charge are delocalized overall the benzene ring. When comparing these two, phenol and phenoxide ions, phenoxide ion is more stable than phenol because of phenoxide ion is a phenoxide ion. In phenoxide ion, there is no charge on oxygen and stable resonance structures in phenoxide ion. And you can observe the one more carboxylic acids also. In carboxylic acid RCOH plus H2O gives RCOO minus plus H3OH. RCOO minus means carboxylate ion. Carboxylate ion. Here carboxylic acid. In carboxylic acids also proton donors. Carboxylic acids donate protons to form carboxylate ions. Here you can observe the carboxylate ion resonance structures. This type of resonance structures are possible. Equivalent resonance structures. Here the negative charge is lie over two oxygen atoms. That means the negative charge rotates these two oxygen atoms. When comparing with phenols, carboxylic acids are more acid than phenols. Carboxylic acids are more acidic in nature than phenols. If minus plus M groups and minus M groups, how affect the acidity of phenols and carboxylic acids. The acidity of phenols and carboxylic acids is depending on the dissociation of O bond H. That means the release of proton. When plus I groups or sorry, when plus M groups are there, plus M groups, electron releasing groups decreases the acidity. Electron releasing groups decreases the acidity of phenols and carboxylic acids by because of they increase the electron density and OH oxygen and reduce the OH bond dissociation with results in the release of fewer of protons. When electron attracting groups or electron withdrawing groups increase the acidity of proton, electron withdrawing groups increases the acidity of protons because they decrease the electron density on OH bond, decrease the electron density on OH bond or OH oxygen and increase the OH bond dissociation. And the next one, basicity of amines. Basicity of amines. Aniline, this one is aniline. Aniline reacts with water, it will give NH3 plus OH minus. In this example, you can observe aniline means amines obstruct protons H plus S. It attracts protons. That's why these are the bases. These are the bases. Aniline is a weaker base because of delocalization of lone pair of nitrogen through resonance or mesomeric effect. You can observe this resonance structures of aniline. Resonance structure, nitrogen is having lone pair of electron. This lone pair of electron donates to the benzene ring. Here the electron shifted to this carbon. This is the minus charge electron shifted to this carbon. These are the resonance structures of aniline. Here same electrons negative charge is delocalized through the aromatic ring throughout aromatic ring, then aniline is formed. And this is the resonance hybrid structure of aniline. Resonance hybrid structure of aniline. NH2 dot resonance hybrid structure of aniline. Here also electron releasing groups increase the basicity of aniline. Electron releasing groups, that means plus M group, electron releasing groups means plus M groups increase the basicity of aniline and electron withdrawing groups decrease the basicity of aniline. Electron withdrawing groups decreases the basicity of aniline. The basicity is depending on the electron donation on nitrogen atom. Nitrogen is having lone pair of electrons. If the nitrogen is donating electrons to electron deficients or protons, it if nitrogen donates electrons easily, it is a strong base. Finally, I can write here plus M and minus M groups are there. Acidity and basicity. Plus M groups decreases the acidity, minus M groups increases the acidity. Plus M groups increases the basicity, minus M groups decreases the basicity. This one is the final. Plus M groups means electron donating groups increases basicity, decreases acidity. Minus M groups, electron withdrawing groups increases acidity, decreases basicity. Thank you.